we're going to talk about review of polar curves. And before we get started, I'm going to share my screen here. This is the polar packet that I'm going to work through. I wanted to let you know that I have posted this polar curve summary on Moodle for you to look at and to have as a resource. We did this last time. We did limicons with inner loops, and we knew that the cosine had curves that were on the left or the right of the polar plane based on if I had a positive cosine, the biggest part was on the positive part of the polar plane. And then if I had a negative cosine, it was flipped to the left side of the polar plane. Okay, so a limicon with an inner loop occurred here when the amplitude was bigger than my midline because it would dip below the polar axis or the theta axis. I had a cardioid when I bounced off the polar axis and the amplitude and the midline were the same. Again, this is a positive cosine, so it's on the positive side of the polar plane. And this is, if it was negative, it would be on this side. And then we'd have a dimpled limicon if we had the amplitude being smaller than the midline because you never reached the pole. Because if you think about this, right, this cosine curve is floating above the theta axis. And what I didn't talk about last time was the difference between a limicon with a dimple and a convex limicon. And basically, if the ratio of your midline, the midline is A, so 6/4. If that's less than, if it lies between 1 and 2, and 6/4 certainly does, then it bows in a little bit. And if it's greater than or equal to 2, that ratio of the midline to the amplitude, and I don't necessarily love the fact that A is not the amplitude, but that's all right. I didn't make the sheet. I'm borrowing it. The midline over the amplitude, if that ratio is bigger than 2, then it doesn't dip in as much. It's convex, meaning it's not. It doesn't bow in. It just kind of doesn't have a dimple. Okay. But my biggest thing is that that it doesn't ever reach the pole because the midline is larger than the amplitude. So this cosine curve is way above the polar axis. All right. And then we talked about in the second day that we did polar curves, we talked about rose curves. And we have, if you have n, which is the period factor here, the b, if it's an odd number, then you had an odd number of petals. Okay, if n was even, you had double the number of petals. So for example, this one here is 5 cosine 3 theta, so I have 3 petals, and you see we do here. And this is 4 cosine 6 theta, so I have 12 petals. And it's the same for sine. If you have an odd number here, you have an odd number of petals, and it's the exact same number as the b factor or the period factor. And then for 4 theta, we're going to have 8 petals. All right, and we can have a circle. If you have r equals cosine theta, you're going to have either on the positive side of the polar plane or the negative side of the polar plane. And if the cosine's positive, it'll be on this side. If cosine's negative, it'll be on this side. With sine, if it's positive, it'll be up. If it's negative, it'll be down. And then I talked to you briefly about a lemniscate. And that's where you have an r squared situation and a double angle. And if I had time, it would be really great if I did have time. I would talk to you guys about some other cool things that we could do with polars. But with our situation being remote, I'll get to it next year. We'll fill you in next year. But today I'm just going to talk about circles, limicons, cardioids, and rose curves and lemniscates. Okay? All right. So the first problem up on our assignment sheet here, our review sheet, is -4 cosine theta. Now, -4 cosine theta, if I were going to graph it on a polar graph, I would say that it is a negative cosine curve, so it's going to start down in amplitude. And its period is 2 pi, so we're going to go from 0 to 2 pi. And I'm plotting my points here. And I would start down in amplitude, go back to the midline, up in amplitude, back to the midline, and down in amplitude. And then I would connect the pretty dots here. Okay? And let's graph our polar points for review. So I'm going to go -4 out radially, 1, 2, 3, 4, 0. And then at pi over 2, or when r is 0, I'm at the pole. So I have to go, now remembering that theta is positive and increasing, that means I'm rotating counterclockwise to get there. So I'm going to go back to the pole, there it is, back to the pole. And then I'm going to go out radially 4, 1, 2, 3, 4, and then rotate pi. And so I have to go from the pole, and r is getting bigger, so I'm going to go here, and I have a circle. So this is a circle, but we knew that was a circle. And its center, because the instructions say, is it centered at the pole? Is it on the polar, I should write this as polar axis? Or, the y-axis, right, which is the axis that shall not be named on the polar plane. So this is a circle with the center on the polar plane. I can't spell polar. I are an engineer. On the polar axis, I'm sorry. And this circle is centered at -2, 0, and this is not r theta, this is xy, just to remind you, okay? But right, because the center here is at 2, 0, rectangularly. Okay, the second one, r equals 4. I took the liberty of writing this up before we started. So r equals 4. If I were to graph that, r is always 4. It's never changing. It's always 4. It doesn't matter what theta is. So let's say theta was 0. R is 4. So theta is 0. We're going to go out radially 4. 1, 2, 3, 4. Great. Theta is pi over 6. What is r? 4. So go 4 pi over 6. Pi over 4. Pi over 3. So do you see how this is a circle? I can draw a circle. This one is a circle with a center at the pole. And so when r is equal to a constant, you're going to have a circle centered at the pole. I should label this as r and theta to be precise, and this is 4, and this is r and theta. Okay? All right. Theta equals pi over 4. If I were to graph this one, theta equals pi over 4, on my r theta, theta is pi over 4, so that means theta is always pi over 4, so I'm going to put a pi over 4 here, right here. It's a vertical line on this chart, okay? So if theta is always pi over 4, does it matter what r is? No, so I could say r is 1. And if r is 1, I'm going to rotate pi over 4. What happens when r is 3? 1, 2, 3. I'm going to rotate how far? Pi over 4. And vice versa, right? So do you all see that this would be a line passing through the pole? Through flow. Through the pole. Oh my goodness gracious. I'm being dyslexic today. Happens. All right, the next one is r equals -4 theta. Goodness, what does that look like graphically? Well, if I'm doing r theta, let's look at it analytically. R theta, that's going to be a line here with a -4 slope passing through this point here, okay? Now this one's a little bit difficult, a little tricky, but not really. So let's just do an r theta to make ourselves feel better. I'm going to choose a theta that's nice. First, I'm going to choose 0. Well, if theta is 0, r is 0. That's nice. If theta is pi over 4, now why would I choose pi over 4? Well, because the 4's cancel. And so then I get -4 times pi over 4 is -pi. What happens if I choose pi over 2? Because that'll be a nice number to cancel out. We get negative 2 pi. What happens if I let theta equal 3 pi over 4? Well, that's not over 4 here. That's negative 3 pi. I think we're seeing the pattern now, right? What if I let it equal pi? Theta's pi, then r is negative 4 pi. Okay, so what I'm going to do is now we're going to put these in increments of pi. You know, my r, here's pi, this would be 2 pi, this would be 3 pi, this would be 4 pi, okay? So I'm starting at the pole, here we go, starting at the pole, and then I am going to go out radially negative pi, which is right here. My first circle now has this. Remember, my radius is on this polar plane are in increments of pi. I think that's just going to make it easier to graph. I'm going to go out radially negative pi and rotate how far? Well, I'm going to rotate pi over 4. And since theta is positive, right, we're going to go counterclockwise. So it's going to be 1 pi over 4. Did I get halfway? There we go. So I'm going out radially pi over 4. Rotating pi over 4. Then we're going to go out radially negative 2 pi, which would be 1, 2, because they're in increments of pi. And then I'm going to rotate pi over 2. So I'm going to end up here. This is 1, 2, rotate pi over 2. So I'm going to go out radially pi over 2. All right, and then I'm going to go out radially negative 3 pi. 1, 2, 3, that's negative 3 pi. And I'm going to rotate to 3 pi over 4. So 3 pi over 4 ends up in the middle over here. So what's happening? Oh no, we're going to go to negative 4. 1, 2, 3, 4, negative 4 pi. Then I'm going to rotate pi, which puts me on this axis here. What's happening? We're spiraling out of control. And if we, right, if I went 5 pi over 4, we would get negative 5 pi. So I'm going to go 1, 2, 3, 4, 5. And then I'm going to go 5 pi over 4. So we're going to go all the way around to 5 pi over 4 right here. And so what's happening is I'm spiraling from the pole outward. So this is a spiral. So let's write it on our thing here. Oh, I forgot to write that this was a line. Through the pole. Should follow my own directions, right? Through the pole. This one is a spiral out. Now, what do I mean by that? As theta gets bigger, I'm spiraling outward. And if we were to keep going, we would end up at 6 here, I believe. 1, 2, 3, 4, 5, 6, right? And we would keep going and going and going and getting bigger and bigger and bigger. And it's like, are we getting sleepy? Right, okay, so that's a spiral out. For sine theta, and I'm going to let you predict, where is that one going to be? Well, that's a circle because we don't have a b factor here. It's a circle, and its diameter is 4, so its radius is 2. But if we weren't sure, we could draw a quick r theta chart, knowing that sine starts, I heard it from the back, sine starts on the midline. All right, so here we go. We're going to start on the midline, go up and down, and then up again. And these are our points, remembering that's pi over 2, and this is 3 pi over 2. Okay, so let's, this is r, and this is theta. Okay, so I'm starting at the pole, and remembering that theta is going positively, I'm rotating counterclockwise. R is 4, so I'm going out radially 4, 1, 2, 3, 4, and rotating to pi over 2. But r is getting bigger, so I'm going to rotate out. There we go. And then what happens? I go back to the pole. And if I were to keep going, let's see what happens. If I were to go out negative 4 radially, 1, 2, 3, 4, because that would be my next point, wouldn't it? And then I rotated 3 pi over 2, where would I be? I would be up here. So I'm just redoing my circle. The more I do this, it's like this is one petal, but it's not a petal because it's a circle. This is not a one petal rose. This is just a circle. Okay. But it only takes us 1 or half a period in order to get just the full circle, which is kind of cool. All right, this next one. So we're going to say this is a circle. Sorry, let's finish our thoughts here. A circle, and it's got a center on the, and I'm going to, use y-axis for lack of a better phrase. It's on the center on the y-axis. It's actually 0, 2 in rectangular form. In polar form, it would be 2, pi over 2. That would be the center. But all right, this next one, r equals 4 over theta. Well, this one's a little trickier. I'm not going to lie. It's a little bit trickier. But I want to try to sell it to you this way. Let's do the r theta chart here. And this is a rational graph. If we think about 1 over x, 1 over x looks like this, or 4 over x looks like this, doesn't it? If we roll back the tape in our mind when we were doing rational functions. Let's say theta is 1. What is r? Well, r is 4. Okay? So r is 4 when theta is 1. Now, why can't I let theta equal 0? Well, if I let theta equal 0, gosh, what's happening is as theta gets closer and closer to 0 here, what's happening to r? R is getting infinitely large. R is getting infinitely large. It's almost as if I take the limit as theta approaches 0. You can't see what I'm writing, I'm sorry. The limit as theta approaches 0 from the positive side of 4 over theta is equal to infinity. And so what does that mean? That means that r is approaching infinity, basically. So when theta is 0, I'm coming from way out at infinity, right? Well, theta can't ever equal 0, but let's just put in 1 over 100. Let's say theta was 1 over 100, because that's pretty small. That's pretty close to 0. If I put in 4 over 1 over 100, what is r? Well, r is, 400, isn't it? It's way out here in the positive realm. So what happens if theta is 4? That's a nice number. Let's try 4. 4 over 4 is 1. So r is 1. So I'm going to go out 1, 2. I'm going to go out 1 and rotate 4. Well, where's 4? Well, okay, so this is pi over 2, which is 1.571. This is pi, which is 3.1415. This one is 3 pi over 2 down here, which is 4.71, right? And so we're kind of somewhere in the middle here. So we're going to rotate out. I'm trying to think about what 5 pi over 4 is. I'm going to find that out so I don't tell you a lie. 5 pi divided by 4 is 3.9. That's close. 3.926. So it's almost. So I'm going to go out radially 1, and I'm going to, out radially 1, and we're going to go almost to 5 pi over 4. Okay? So what's happening, though? What happens when theta is 2? Then r is 2, isn't it? So we're going to go out radially 2, 1, 2, and then go 2. Well, 2 is greater than 1.57. And so we'll just put this over here somewhere. So what's happening is r is huge. And so r is spiraling in towards the pole. Now, why do I say spiraling in towards the pole? What happens when theta gets really large? Now, when I say really large, let's say 8. Let's try 8. When theta is 8, what do we get? We get r is 1/2. So if r is 1/2 when theta is 8, theta is 8. That's 6.28. Theta is 8. So what is 5 pi over 2? That's about 7.8. So it's, you know, theta is 8. It's going to be all the way around. But r is 1/2. It's really small here. So it's going to be all the way around and then some. So maybe over here, closer to here. So what's happening is we're spiraling in here to get to the pole. So this is a spiral in. So you know it's a spiral in because what happens when theta gets really large? What's happening to r? R is going to 0 almost. You see how it's going into 0. And then when r gets close to 0, r is huge. So when your angle is 0, r is like at infinity. So it's like way out here. So it's coming in and zooming in to the pole as theta gets smaller. I'm sorry, as theta gets smaller, we zoom out to infinity for r. And then as theta gets bigger, we're zooming in on the pole. So this is a spiral in. Now, when do we have spiral ins? When we have rationals, where the theta is in the denominator. When do we have spirals out? When the theta is not in the denominator. You're like, whew, okay. All right, so I don't expect you to memorize that. And, you know, maybe the spiral or something in or an out would be a bonus on a quiz or something, but not anything you have to worry about. Okay, so r equals 6. What do? R is constant, right? R is constant. It's 6 forever and always. So it doesn't matter what theta is, right? So you could plot some thetas if you like. Let's say theta is 0. Well, theta is 0. I don't have a place to put it, so r is 6. 1, 2, 3, 4, 5, 6. This is very faint. Sorry about that, but my printer was not a happy camper. All right, so this is a circle centered at the pole because r is always 6. Okay, so this next curve says, well, theta is equal to negative 5 pi over 6. Well, where is negative 5 pi over 6? Well, if I start from standard position, negative 5 pi over 6 is over here because this would be pi over 6, pi over 6. So here it is. This is a line, and my theta here is negative 5 pi over 6. Could we call this another name? We could say AKA, what's another angle this could be? Theta equals pi over 6. Sure, that's the same line. Could we call it another name? Sure, we could say theta equals 7 pi over 6. They're all the same line. A line of many names. Okay, next one, 6 cosine theta. All right, so if I were to graph the 6 cosine theta, it's got an amplitude of 6. Its midline is 0, and I don't have a period factor, so the period is 2 pi. And this is a cosine curve, so we're going to start off the midline and up because it's positive. Here we go. There it is. It's positive. And if I go out radially 6, rotate 0. 1, 2, 3, 4, 5, 6. Rotate 0. Go back to the pole. Remember, we're rotating counterclockwise. We're going to go back to the pole. And then I'm going to go out radially negative 6. 1, 2, 3, 4, 5, 6. And then rotate pi. And then I end up here. So from the pole to here gives me, what, a circle. I got to turn the light on. I'm sorry. It gives us a circle centered on the polar axis. And is it on the positive polar axis? There we go. And then there was light. And I think I just turned it off. It's on the positive polar form because this is a positive cosine. Good. All right. And what this circle has a center at 3, 0. Now remember, this is 30 XYville, not Polarville. Okay, and the diameter, notice the diameter is 6. The diameter is always the amplitude. All right, this is a sine curve here, a sine curve, -4 sine theta. If you had to be a betting person, where would it go? You're right, it would go down here. And what would its diameter be? Its diameter is going to be 4. 1, 2, 3, 4. And I'm going to draw it, but then we're going to prove it to ourselves. Because on any quiz I give you, I'm going to want you to show me that you know how it works that way. And so I'm going to want this curve. Okay, this is a sine curve that starts on the midline and goes down in amplitude, back to the midline, up in amplitude, and back down to the midline. And here's my curve. And so I start at the pole at 0, 0, and then I'm going to go out radially -4, 1, 2, 3, 4, and then rotate pi over 2. It puts us at this point, and then we're going to go back to the pole at pi. And now I have the fan too high. There we go. I'm on my back porch, and it's so pretty out tonight, so I figured it would be a good night to do it out here. All right, so this is a circle with radius of 2, and the center here in the XYville is going to be what? 0, -2, and that's XY. Okay? Next one. Oh, wow, the next one looks interesting. 3 over 2 theta. Well, goodness, there's not a sine or a cosine or anything. I think this is a spiral. Is it spiraling in or is it spiraling out? Well, the theta is not in the denominator, so it's spiraling out because it's going to start at the pole, and then theta, as theta gets bigger, what's happening to r? R gets bigger. So we're going to start at the pole, and let's put in theta. Let's do a little R chart because I know some people are uncomfortable with these. So let's make theta pi over 4. No, let's not make theta pi over 4. I don't like that. Let's make it pi. If I make theta pi, then I have 3 pi over 2 is r. Do I want to do that? Yeah. Well, let's just make theta 1. That means r is the theta is 1, then r is 1.5 or 3 halves, right? So I'm going to make this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, I'm going to make them in increments of 2 over 1/2. Okay, so theta is 1. 1 radian. Oh gosh, let's review. 1 radian is about, right, 57 or 60 degrees or close to. And so we're going to go out radially 1.5, which puts me here, and rotate to about almost pi over 3. So what's happening? I'm starting at 0 at the pole, and then I'm going to rotate radially out. All right, so let's make theta 2. And then that's going to give us 3. So we're going to go out radially 3. 1, 2, 3, and rotate 2 radians, which is almost 120, right? Or 2 pi over 3. So we'll put it over here. Am I on the right? No, sorry, here. I should be here. And so what's happening is I'm spiraling outward. Okay, so let's make theta a nicer number. Let's make it, we did 2, let's make it 4. So if theta is 4, then we are at 6. So I'm going to go out radially 6, which is out here, and then we're going to rotate 4 radians, which is just in this quadrant over here. So we're going to go out 6, which is out here, and then we're going to rotate to about 4, because this is 4.71, so right about here. So we're spiraling out. And if you don't believe me, let's graph it on Desmos. R equals 3 divided by 2 times theta. And see how it spirals out really fast? So there it is. We just confirmed what we were doing. I love that. Okay, let's do another one. R equals -5 over theta. Ooh, -5 over theta. So -5 over theta, remember 4 over theta was in the first and the third quadrant. So this one's going to be like this. So what's happening? The limit as theta approaches 0 now from the positive side. What's R going to be close to? So remembering that this is R and this is theta. This is approaching what? Negative infinity, as you see. It's approaching negative infinity, which means it's way out here. Okay, and then so it's going to spiral in. Okay, so let's do a couple of points here. What would be a nice point to put in there? Well, I think 1 would be a nice point to put in there. When I put in 1, we get -5. So if I go out radially -5, 1, 2, 3, 4, 5, -5, and I rotate 1 radian, which is about 60 degrees roughly, or pi over 3. So I'm going to be, whoops, I need to be on this outer edge here. All right, so let's put in another nice number, which would be 5. What if I was at 5 radians? That would be -1. So 5 radians, -1. So I'm going to go out -1 and then rotate 5 radians, which is about just beyond, right? Because this would be 1.57, 3.14, and this is 4.75. So I'm going to be I read 1 right about in here somewhere. So what's happening is I'm going from infinity and spiraling inward. Now the question is, do I ever get to the pole? Remember, this is the pole. Do I ever get there? The answer is no. So I'm spiraling in and in and in and in. So let's prove it to ourselves. R equals -5 divided by, can I spell theta? Okay. And you'll notice on this graph, you still see it, right? Oops, you still see, we're never reaching the pole. We're never reaching the pole because we're never going to reach 0 here, which is pretty cool. So this is a spiral in. And it's spiraling in from the negative side because this R is going to negative infinity. So R is negative infinity out here and it's spiraling in, right? R is negative infinity and R is getting smaller and smaller and smaller from the left side, okay, on the negative side. All right, let's leave spirals alone for a while and go to something we're more comfortable with. This is a cosine curve with no period change, and the midline is 3. Amplitude is 3. So this is 0. Oh, sorry, try again. The midline is 3, this is 6, and this is 0 here. So what's happening is this is a cosine, and with no period change, I still have those nice, pretty increments we know and love as pi over 2, pi, and 3 pi over 2. And I'm going to start at up in amplitude, because this is a positive curve. This is r and this is theta. I'm going to go to pi over 2, pi, back to the midline, right? And then up in amplitude. I'm going to graph my cosine curve really quickly. And then we're going to plot some polar points. And so I'm going to notice right away here we're bouncing at the pole. And since we're bouncing at the pole, this is a cardioid. All right, and which side is it going to be on, this side or this side? Because it's a positive cosine, everybody knows it's going to be on this side, the big part. Okay, so let's start out at 0. R is 6, so I'm going to go out radially 6. 1, 2, 3, 4, 5, 6. And then what happens? I'm going to go to 3. 1, 2, 3. Go radially to pi over 2. There we go. So R is going to get bigger. I mean smaller till I get to pi over 2. And then I'm going to go to the pole. R is 0, so I'm going to go to the pole at pi. And then I'm going to bounce off the pole. And then I'm going to go out radially 3, 1, 2, 3, and end up at the 3 pi over 2 point, 1, 2, 3, right here. And it's probably a little bit smoother than this, you know, like, it doesn't have to be perfect. Right, and there's our cardioid. And we know we're bouncing off the pole, not passing through here. All right, next one. 4 minus 4 sine theta. Now that's a sine curve, so it's either going to be up here, the big part, or down here, the big part. But this is negative, so the big part's going to be down here. All right, and this one, it's got a midline of 4. 1, 2, 3, 4. And so the amplitude up here is, the highest part is going to be 8. And this is a sine curve with no period changes, so it's going to be our increments we know and love, pi over 2 to pi to 3 pi over 2 to pi over to 2 pi. And this is a sine curve, so we're going to start on the midline, go down, amplitude back to the midline, and up in amplitude, and then back to the midline, and we're going to graph our pretty curve, trying to make it through all the points. All right, so the first point, polar point we're going to do is out radially 4. 1, 2, 3, 4, and I'm not rotating any angle. Then we're going to go back to the pole before we get to pi over 2. There we go. There's back to the pole. I'm going to bounce off the pole here, and then we're going to go radially out 4. 1, 2, this is 4, I'm sorry. And then we're going to rotate to pi. That's our next point. So we're going to bounce off the pole and go up to pi. And then we're going to go out radially 8. This is 4, 5, 6, 7, 8. And then we're going to rotate to 3 pi over 2, which puts us here. So from this polar point, we're going to go to this polar point. And then we're going to go back to out radially 4 and rotating 2 pi. So we're going to come back home. And this is another cardioid. And it was as we expected. The large part was on the bottom. Okay, next one. 4 plus 6 cosine theta. 4 plus 6 cosine theta. What's our midline? Well, our midline is 4. So 1, 2, 3, 4. And our amplitude is 6. So 1, 2, 3, 4 is 4. And then this is going to go up to 10, right? Because the amplitude is 6. And then what does it mean down here? That means we're going to go down 2 below. And our increments and our nice polar points are not condensed with any period changes. All right, so there's a cosine curve starting up and off the midline, to the midline, down, back to the midline, and up again. And here we go. We're going to plot our polar points, our curve, and then plot our polar points. So we're going to go out 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plot my point. Thank goodness I had 10, right? I might have to make these in different increments if I didn't. And then we go to out radially 4 and rotate 1, 2, 3, 4 to pi over 2. Now, right here, ding, 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 we're passing through the pole, which means this has an inner loop. So this is a limison, before we start, we even know that this is a limicon with an inner loop because I passed through the pole twice. I'm not bouncing off the pole like I was bouncing off the pole here, bouncing off the pole here. We are not bouncing off the pole here. We're passing through the pole to get to our next point. So what is our next point? Well, first of all, let's graph this. R is getting smaller till we get to this point. Okay, and then my next point that I'm going to go to is -2 out radially, 1, 2, and I'm going to rotate pi. So I'm going to here. So I have to pass through the pole to get there. So here we go. I'm going to pass through the pole to get there. Not very smoothly, I might add. Pass through the pole to get there. And then once I'm here, I'm going to pass through the pole again to get to the next point. The next point is going to be 4 out radially. 1, 2, 3, 4. 3 pi over 2. So we're going to rotate to 3 pi over 2. 1, 2, 3, 4. So we're going to pass through the pole and end up here. And then we're going to go back out radially 10 and then rotate 2 pi. So we're going to come back home. There we go. Nice. And if I had more time, I would work out with you how we find out what angles will actually, give us this inner loop. Okay, this one here, I have a midline of 7. Holy jeepers, 7's pretty high, so I'm going to put 7 here. And an amplitude of 2, but the B factor, the period factor is 1, so we still have our nice increments. Okay, and what's our amplitude? It's 2, so we're going to go up 2, which puts us at 9, down 2, which puts us at 5. We're going to start on the midline because it's a sine curve, and then we're going to go down in amplitude, back to the midline, up in amplitude, and back to the midline, and then graph our sine curve really quickly. All right, now you'll notice here, if this is R and this is theta, do we ever get to the pole? No, we never reach the pole because this is the pole down here. So this is either a dimpled limicon or it's a convex limicon. So let's go out radially 7. 1, 2, I can't see this late at night. So here we go. 1, 2, 3, 4, 5, 6, 7. And we're rotating nothing. Then we're going to go out 5 radially. 1, 2, 3, 4, 5. And then rotate pi over 2. Here we go. And then we're going to go to 7 and rotate pi. So 1, 2, 3, 4, 5, 6, 7. And this is a convex one because the ratio of the midline to 2 is greater than 2. So this is a convex limicon. And it never reaches the pole, so I don't have any inner loops or I don't bounce off it. Okay, and then I'm going to go to 9 at 3 pi over 2. Now I know 9 is here. So if I go out radially 9 and rotate to 3 pi over 2, I'm going to end up here. And then we go back to 7 and rotate 2 pi, so we're going to go back home again. So you'll notice that this looks like a circle, but it's not really. It's a convex limicon because of the ratio here. But the larger part, though, is below because this is a -2 sine theta. It would be this way if it was +2 sine theta. All right, let's do another one. 5 minus 3 cosine theta. What's our midline? 5. Here it is, 5. Our amplitude, I'll make this a little bit different here. Our amplitude is what? 3. So their amplitude is 3. That's going to put us at, I have to go down 3. So that's going to be 2. And then up 3, which will put us at 8. And our increments and stuff are still the same, which is really nice. Okay, and we're going to start off the midline and down in amplitude. So we're going to start here at 2, back to the midline, up in amplitude, back to the midline, down in amplitude. Here we go. Here's our curve. And we're going to, this one here, what's the ratio of the midline to the amplitude? That's 5/3. And 5/3 is, all at once, everybody? Is that less than 2? Yes, that's less than 2. Because if it was 6, that would be equal to 2. Okay, so let's plot some polar points. We're going to go out radially 2, rotate nothing. And since this is a negative cosine, I'm anticipating the big part's going to be on this side. All right, so then we're going to go to our next point, which will be at 5, out radially, 1, 2, 3, 4, 5, and then rotate pi/2 right here. And then we're going to rotate, or go out radially 8. So this is 1, 2, 3, 4, 5, 6, 7, 8. I'm going to be at pi. I should have gone this way. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I have to count out loud in order to get to the right place. So here we go. And then what? I go to 5 and rotate to 3 pi/2. So out radially 5 and rotate to 3 pi/2. It puts me down here. 1, 2, 3, 4, 5. Oops, I should put a dot here so I know where I'm going. And then I go back home again. I go out radially 2. And this one is the dimpled one. So it's going to bow in just a little bit at 2. And the bigger side is on the left side. All right, next one. We're going to predict, right? This is 3 plus 4 sine theta. What's the midline? Well, it's 3. Put the 3 here. The amplitude here is 4, so that would be a 7. And if I subtract 4 from this, I'm going to be at -1. So this is going to be what? Well, I'm going to dip below. So this is going to be a limicon with an inner loop. And let's put in our little, numbers here for our interval. Our theta values there, our increments. I'm going to start on the midline, and since this is a plus sine curve, I'm going to go up in amplitude, back to the midline, down in amplitude, so I'm going to be down here, and then back to the midline. So here's our curve. And we're going to go out radially 3. 1, 2, 1, 2, 3. Put my point because I'm not rotating any. Then we're going to go to 7. 1, 2, 3, 4, 5, 6, 7. Rotate pi/2. So we're getting bigger till we get to pi/2. And then we're going to go out radially 3 and then rotate to pi. So that's 1, 2, 3. We're going to go down to pi. And then we're going to go through the pole. Now remember, that's the pole. And that's the pole. So we're going to go through the pole to get to our next point, which is going to be at -1 radially, and then rotate to 3 pi/2. So 3 pi/2 is going to be here. So we're going to go through the pole and hit this point here. And then we got to go through the pole again to get to the next point. So we're going to go out radially 3. 1, 2, 3, and rotate 2 pi, which puts us back home again. So we got to go through the pole and get back home again. This is a limicon with an inner loop. Now, how do we know the difference between a dimpled limicon and a limicon with an inner loop? Well, you'll notice that when you have an amplitude that's smaller than your midline, you're never going to reach the pole because this is the pole. And if you have an amplitude that's bigger than your midline, you're going to dip below the pole. So you're going to have to pass through the pole. And that's going to give you the limicon with the inner loop. And you know that you're a cardioid if you bounce when these are the same. Okay, so these next ones I'm going to challenge you for practice to do, and I will post the answers to these, okay? All right? So I want you to graph them, but I want you to kind of predict, if you can, what you're going to get beforehand. So let's pause the tape. You pause the tape or the video and see if you can identify what they are, and then hit play again, and then we'll get back together. But I'll put the solutions to these graphs on Moodle, but I'm not going to graph them all right now by hand. I'll let you practice these, okay? So pause the video and then write what you think these are, and then come back to me. 3, 2, 1, go. All right, well, this is going to be a circle of radius 2, centered at 2, 0. And remember, that's xy 2, 0. This is going to be a convex lemniscate, with the biggest portion of it being below the axis, the polar axis. And why is it a convex lemniscate? Because the ratio of the midline to the amplitude is greater than 2. Okay. This right here, we haven't talked about this yet today, but this is a rose curve with 20 petals of length 7. R equals 6 theta. Well, this is a spiral out, because we start at the pole when theta is 0, and as theta gets bigger, r gets bigger. So we start at the pole and r gets bigger and bigger and bigger and bigger. So this is a spiral out. Okay, this next curve, 4 plus 7 sine theta. Well, this is a lemniscate with an inner loop. Now, why is it with an inner loop? Because this 7, the midline is smaller than the amplitude. So that means this is going to dip below the pole. So this is a lemniscate with an inner loop. R equals 4 over theta. Well, what happens? This is a spiral. And this is a spiral in, because when theta is 0, r is huge, and it spirals in, and it will never get to r equals 0, because as theta goes to infinity, this approaches 0 but never reaches. So this is a spiral in. R equals -2 sine theta. Well, that's a circle of radius 1, and that's below the polar axis, and it's centered at 0, -1 if I'm using x and y coordinates. Okay. R equals 6 plus 6 cosine theta. Yeah, this is a cardioid. Now, why is it a cardioid? Because these are equal, and we know it's going to bounce off the pole. And where is the biggest side going to be? It's going to be on the right side, because this is positive, right? So I was guessing it would be like, right? Okay, 8 cosine 5 theta. Well, this is a rose curve with how many petals? You're right, 5 petals of length 8. R equals -8. Now, we didn't do an R of -8, but that just means I'm rotating. You know, I'm starting at -8 and I'm rotating with all my angles. So it's still a circle centered at the pole. It just starts at -8 radially, and then you rotate this way. All right, 8 plus 6 cosine theta. Well, guess what? This midline is really huge, right? So this is what's the ratio? It's 8, the midline, over 6. This is less than 2, so this is a dimpled lemniscate. All right, and we haven't talked about this one yet, but this one is a lemniscate with loop length 5. And this one, if we were going to graph it, would go out 5, and it'd be -5, and it's going to be our nice infinity symbol here. Okay? All right. Well, hopefully you got all of those right. But if not, we're going to practice a little bit more, and then I'll finish. Hopefully you're going to listen to me on double speed. All right, here we go. Cosine of, r equals 6 times sine 2 theta. 6 times sine of 2 theta. Well, what do we know about it? Well, we know that we have a b factor here that's 2. And so it's even. So we know already before we start that this is a rose curve with 2 petals. I'm sorry, try again. 4 petals because the b factor is 2. So this is 4 petals. And we know the length is 6. But let's graph it here. So I'm going to start, we got a midline here. And my b factor here, b equals 2. So the period is what? 2 pi over 2, or pi. And the increment is 1/4 of that, which is pi over 4. Okay, so here we go. We're going to put pi here. And this is pi over 4, 2 pi over 4, and then 3 pi over 4. And I have to do 2 periods of this because this is a 4-petal rose, I know. So this is going to be 4 pi. Sorry, put this 4 pi over 4, and then 5 pi over 4, 6 pi over 4, and then 7 pi over 4. All right, so the amplitude is 6. -6 is a positive sine curve, so we're going to start at the midline, up, back to the midline, down, back to the midline, up, back to the midline, down, back to the midline. And here's our sine curve. Good, and where do we start? Well, Mrs. Muller, we start at the pole. You're right. We start at the pole. And then what are we going to do? Well, we're going to rotate out to our max petal length at pi over 4. So we're going to go at 6, 1, 2, 3, 4, 5, 6. Rotate to pi over 4. R is getting bigger, and then I'm going to go back to the pole. There we go, back to the pole. Nice. And then I'm going to go out radially -6. 1, 2, 3, 4, 5, 6. -6, and I'm going to rotate 3 pi over 4. Well, 3 pi over 4 in this positive direction is going to be over here. And so we got to pass through the pole and hit this, and then go back to the pole at 3 pi over 4, right? And now we're at 4 pi over 4. So how many petals we got here? That's petal 1. This is petal 2. And my petals should be uniform. They're not here. But they should be uniform. Okay. The next R is 6, and then we're going to rotate. This is 6, and we're going to rotate 5 pi over 4, which puts me in this quadrant down here. So we're going to pass through the pole and hit this one. Go back to the pole. So we're going back to the pole. And then we're going to go out radially -6, and then rotate to 7 pi over 4, which puts us over here. So we're going to pass through the pole and hit it, and then come back to the pole. And there's our rose curve with 4 petals of length 6. All right, this next one. This one is also a rose curve because I have a b factor. Rose curve with how many petals? 3 petals of length 7. Okay, if I were to graph this really quickly, this is a cosine curve, but it's negative. Now my period factor, I'm going to do some work down here. The period is 2 pi over 3, because the b factor is 3. And then the increment is going to be 1/4 of that. So 1/4 times 2 pi over 3 is equal to 2 pi over 12, or pi over 6. So the increment's pi over 6, and then this is going to be 4 pi over 6 for the period. So here we go, 4 pi over 6. And then half, half, half. And so this is going to be pi over 6. 2 pi over 6, 3 pi over 6, 4 pi over 6. And I'm going to go all the way to 8 pi over 6. So 5 pi over 6, 7 pi over 6, 8 pi over 6. I'm sorry, try again. 1, 2, 3, 4, 5, 6 pi over 6. I can't forget the pi, right? 6 pi over 6, 7 pi over 6. I always have trouble with the problems that are in the upper right-hand part of every page. It's so weird. But anyway, we'll get through it. So this is negative 7. Okay, so amplitude's negative. So I'm going to start down in amplitude, back to the midline, up in amplitude, back to the midline, down, back to the midline, up, back to the midline, down. Now, I may not need all of this curve, but I'm just drawing it anyway. Because how many petals do I have? Well, I have a half a petal, full petal, full petal. So 1, 2, so I only need to go to pi here to get 3 petals, okay? Okay, so let's graph it. What happens here? I'm going to go out radially negative 7. 1, 2, 3, 4, 5, 6, 7. There's negative 7. And I'm rotating nothing. Okay, then we're going to go back to the pole. Now remembering theta is positive and rotating counterclockwise. To get back to the pole, I'm going to go this direction. There we go. Now where do I have to go next once I get through the pole? I have to go to 7. 1, 2, 3, 4, 5, 6, 7 radially, and then rotate to 2 pi over 6 or pi over 3, which puts me right here. So I've got to pass through the pole and hit this point. Right, pass through the pole. Pass through the pole here and hit this point. Then I have to go back to the pole. Here we go, back to the pole. And then I'm going to go to my next point, which means I have to pass through the pole to get to my next point, which is going to be negative 7 and rotate 4 pi over 6, which is 2 pi over 3. So I'm going to start at negative 7, rotate to 2 pi over 3. So we're going to hit this point here and then go back to the pole. And then we're going to come back home again here. So this is going to be passing through the pole. I have to hit 7 pi, which puts me back here. Okay? So there's my rose curve of length 7 with the petals that are length 7, and I have 3 of them. Now, when cosine is negative, the initial petal is going to be on the left side that you draw. When cosine is positive, because you go out radially negative, when cosine is positive, you're going to start on the positive side. All right, this is negative 8 cosine 2 theta. What do we know about it? Well, the B factor is 2, so I know that this is a rose curve with 4 petals of length 8. But this is a negative cosine curve with an amplitude of 8, and it's a negative 8 midline. And the period here is 2 pi over 2 or pi, and the increment is pi over 4. Half, 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 half. Okay, so this is pi over 4, 2 pi over 4, 3 pi over 4. Let's see if I can count better this time. 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. Okay, so we're going to start negative. So it's a negative cosine curve. So I start down here, back to the midline, up, back to the midline, down, back to the midline, up, back to the midline, and down. Here we go. Nice. Okay, now let's graph our first point. Our next first point is going to be negative 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8. I go radially out 8 in the negative direction and don't rotate at all. Okay, then we go back to the pole, but we're going back to the pole going counterclockwise because theta is positive. And so we're going to go rotate this direction. Now we knew it was going to be on this side because it's negative, and we knew it was going to be on this side of the pole, of the polar plane. Then we're going to go out radially. Where's my next point? I got to pass through the pole and hit 8 pi over 2. 6, 7, 8. Yes, I have to count. Sorry, you get to listen to me. Here we go. There we go. I'm going to hit that point. And then I got to go back to the pole. So we're going back to the pole. And then I'm going to pass through the pole, and I have to hit my next point, which is -8 pi. So I'm going to go from here. -8 pi is the next point I got to hit. There we go. And then we're going to go back to the pole. Remember, always rotating counterclockwise. And then we're going to pass through the pole and hit 8 3 pi over 2, which puts us down here. Pass through the pole, hit 8 3 pi over 2. And then back to the pole. That's 7 pi over 4. And then we're going to go to -8 and rotate 2 pi, which puts us back home. So we're going to pass through the pole and come back home. Okay. Now we started on this side because we have a negative cosine curve. And we started on the negative side and rotated. So negative started on this side, okay? Next one, 8 sine theta. Oh no, the b factor went away, which means this is no longer a rose curve. This is a circle with radius of 4. Because remember, the coefficient here is the diameter. Okay, but we're going to graph it to prove it to ourselves. My amplitude is 8. And it says a sine curve. And I have a 1 period factor, so this is going to be our nice numbers again. We're going to start on the midline, up in amplitude, back to the midline, down in amplitude, back to the midline. Here we go. Nice. And we start at the pole, and then we're going to go to out radially 8, which is the second from the end here, and then we're going to rotate to pi over 2. All right, and then we're going to go back to the pole. And there's our circle. What's our center? Our center is, in the xy terms, it would be 0, 4. Right, that's not a polar point, it's an xy point.